Okay, well today what we're going to talk about is 2-5 literal equations and formulas. Oops, went too far. Um, the objective is to rewrite and use literal equations and formulas. Okay, our standards for today is A1.2.5, add, subtract, multiply polynomials, and divide polynomials by monomials, and A1.2.6, solve equations involving rational and common irrational expressions. That second one you need to write down. Okay, the first vocab is literal equations. That's an equation that has two or more variables. So like x and y, m and n, r and t, um, a and r, something like that. Okay, so for example 1, solve the equation 3x plus y equals 10 for y. Okay, so the first thing I want to do is I want to state what we're after. They want us to solve for y, which means we are solving for this variable right here. So we want to get that variable by itself. It's very much the same thing as what we worked on when we were solving equations for one variable. Okay, the only difference now is that when you take things to the other side, you may have a variable in there. Okay, don't worry about simplifying it down. You don't have a value for that variable, so you just kind of remember the rules of combining like terms. Okay, so again, I'm going to write this line up here to make it a little familiar to what we've done in the past. We have y. That's what we want to isolate. Okay, just like when we were isolating x's in one-step equations, we're doing the same thing here. So there's adding 3x with that, which means that we need to get rid of this 3x. We do that by subtracting. So remember that from one-step equations. We subtract 3x. Well, when I do that, 3x minus 3x is 0, plus y gives us y. Okay, and then over here we have 10 minus 3x, but we have to remember this is 10 and that's a variable. They are not like terms. So we have to write this 10 minus 3x. You can leave it that way. Some people like to lead with the x. For right now, let's just leave it alone. Okay, so what we have is actually what our answer is. We have y equals 10 minus 3x. Okay, now they have two things over here for us to do. They said, what is y equal to if x is 1 and if x is 3? Okay, so we got two more really steps that we have to do. So let's do the first one. I'll just circle this as like step 1 here. We're going to rewrite this problem y equals 10 minus 3, and then I'm going to put 1 in there. Okay, so we solve for y. Now we're plugging in what the x is. Okay, this is the time where we will actually use what we've written down. So we're going to go ahead and simplify. 3 times 1 is 3. So what's 10 minus 3? Y is equal to 7. Okay, so there would be what our answer is. But like always, we want to check our work. So we're going to say, let's go back and let's check our work. Now always into the printed. So notice we're going to come back to here to do our check. So 3 times, they said x was 1, plus y, which we said now is 7. Now we're getting that from right here. And that should equal 10. 3 times 1 is 3, plus 7 equals 10. 10 equals 10. So it checks out. Okay, so that one worked out pretty well. Okay, so let's go to the second one. We want to solve for when x is 3, so we say y equals 10 minus 3 times 3. Well, 3 times 3 is 9, 10 minus 9 is 1, so y equals 1. Okay, I'll let you do the check on that one. Okay, follow kind of the steps I did here in the green. I want you to go ahead and do that one on your own. Then I'll check that, see how you did. Okay, so problem number 2, what equation do you get when you solve the equation ax minus bx equals c? 4x. So one thing we want to do is we want to specify, okay, we know what we're solving for now. We're solving for x. Okay, so I'm going to write over here, we have ax minus bx equals c. So we want to get these x's by itself. Now the problem here is we have different symbols, a and b, so we can't actually combine these. They're not numbers. They're not like terms really, so we can't combine them. We have to think back to the distributive property, which says that when we multiply something through, we have that quantity in each term. Well, that's what we have. We have x in each term. So if we think backwards, the distributive property, this is what we would have, and we would multiply this x through with a minus sign in between. So what would have to be here to take x times something to get ax? Well, if you thought a, you're right. Okay, what would I have to multiply x by to here to get bx? That would be b. Okay, so that's kind of how you reverse the process. Later on we're going to call this factoring, but right now we're just reversing the process of the distributive property. Okay, and if you check it, x times a, ax, x times b, bx, and a minus sign in between. Okay, so it works out. Now the last step that we have to do really in this case is we have to get rid of this parentheses. That's a quantity. Okay, that's why I use that word quantity, because it's all one piece. So what we're going to do is we're going to actually divide both sides by that quantity, which is a minus b. A minus b. Okay, so we're taking the entire parentheses. Well, something over itself cancels to give us 1, and it gives us 1x. So you're left with c over a minus b. Now we can't simplify this side. This side, it's all letters and they're all different. So therefore we're stuck. That's it. We're done right there. Okay, and really there's not much of a check. We can go over the check in class, but there's really not much of a check that would be simple enough for you to do on your own right now. If we do it in class, I'll show you how that would really work out. Okay, so let's look at problem number 3. What equation do you get when you solve the equation a divided by x minus b divided by x equals c, 4x? Okay, this one becomes a little more tricky because now we have x's in denominators. So as we write this, we have a over x minus b over x equals c. Well, really, if you look at this, this is a fraction. It'd be like saying 1/2 minus 2, or let's say 3/2. Okay, you have x's in the denominators, which are common denominators. So we could actually combine the tops as a minus b over x. Now we can't combine these into one term because they're not like terms. But we can go ahead and make it underneath, with x on the bottom because that's the common denominator. Now to get rid of that x, or to get that x to one side, because that's what we're solving for up here is x, we have to multiply by x to get it out of the denominator, much like we did when we cleared fractions in previous sections. Okay, we wanted to get rid of the denominator. If it was a 4, we would multiply 4 to both sides. Well, in this case, it's an x. It's the same thing as a number. It's just we can't represent it as something familiar as a number. X over x, these cancel. You're left with a minus b. And you can leave that in parentheses. Cx is really just xc or cx, whichever way you want to write it. But we want to solve for x. Now we're multiplying by c. So we actually have to divide by c now. And we get 1x. And over here we get a minus b. Again, still in parentheses there. All divided by c now. Okay, so it's very difficult problems really when you think about it, but if you just follow the same rules that we've been doing and just imagine these letters are numbers, it always works out the same. The problem is that you just can't combine things because they're not like terms. And again, we could do this check, but it'd be really complicated for yourself right now, so we'll do that in class and I'll show you kind of how that works. Okay, we're going to go ahead and stop there. The next video we'll get into formulas.